So hopefully I'm using a different microphone now, so hopefully the audio will be pretty good. I'm going to pull up Mathematica, and so we have a nice big screen, and make it 300%. Okay. Now, bless you. Let's take the derivative of this, and I want you to do this by hand. So here's your function. T cubed. Whoops. T cubed. I want the derivative with respect to time. Quick. Huh? 3t squared. Man, that was easy. Trivial, right? So there's my function, and how do you take a derivative in Mathematica? You say capital D. You can actually spell out derivative, but capital D it takes. There are very few things it'll have shortcuts for, but that's one of them. I want the derivative of the function with respect to t, and sure enough, you're right, 3t squared. Okay. What if you happen to have something like this, where you had a theta, and it's a function of time. So theta is equal to, say, 4t squared, right? And you have another function like x is, I don't know, theta squared. Whoops. Theta squared. What's the derivative of x dt? How do you do that? Huh? Ah, okay, that's where I'm headed. But before I get to the chain rule, is there any other way? Who's heard of chain rule? Who's not heard of chain rule? Okay, well, let me skip past it. Okay, one of the things that you can do is you can take, since you know what theta is, you can put it in here and get t, and then you can take the derivative. Wonderful, okay? Or you could take the chain rule. So, okay, let's jump to the chain rule. Let me quit because I don't want to mess this up, so I'm going to quit. So forget everything that I've done so far. All right, here's what I want to do. I want you to take the derivative of the cosine of theta. That's your function. And I want the derivative with respect to time. Okay, how do you do that? Since you all said maybe I should say it this way. You've heard of the chain rule. Okay, let me ask this other question. Do you know how to use the chain rule? Okay, great. Use the chain rule and take the derivative of f with respect to t. What do you get? You can use Mathematica to do it on the test. I'm not saying you can't. I just want to make sure that, because sometimes seeing the symbols, I think, maybe helps you understand. How do you use the chain rule for this? I want df dt. Okay, so I'm going to see if I can get my iPad up. Okay, so here's my function. F equals cosine of theta. And theta is a function of time, so it changes. And I'm looking for the derivative. Okay, chain rule says you want df dt. Df dt. That's equal to df d, whatever the variable is, in this case d theta, times what? Yep, so basically you have over here f in the top and dt in the bottom, but on the right you got f and a theta. So what you do is you just do this little ratio, d theta dt. Make sense? Okay. What's df d theta? It'd be like dx dy. Remember in calculus, they never have t, I don't think. When I took it, they never had t. It was x and y. Everything was x and y. So they take the derivative with respect to whatever, right? So what's the derivative of f with respect to theta? Derivative of the cosine. You remember that? Minus sine, right. So this would be right here. This would be a minus sine of theta. That's the first term. What's d theta dt? Theta, let's call it theta dot, right? Let's call it theta dot. We've seen those kind of things before. Isn't it the time derivative of theta, whatever it is? Eventually, I hope I know it, but for right now, it's theta dot, right? So what I like to do is over here on the left-hand side, df dt, that's f dot, right? And I think I talked to you about how one of the ways you can tell if you got it right or not. What was that? What? The dots. Count the dots. Okay. This is my the Everett's dot rule. Not really. But anyway, how many dots you got on the left-hand side? One. Because you took a derivative. You should have one, right? You took one derivative. If you take two derivatives, how many dots should be over there? Two. And you remember how to count them? So, for example, if you had something like this, x dot plus y dot, how many dots would you count? No, per term. It's each term, right? So it'd be one. Each term, you see that? If I had something like this, put two dots on that guy, and y times x dot, now how many dots are you saying that you would have? Each term has got two. What if you had something like this, where you had a x with 3 dots, and that guy was left the way it is? So something's wrong. Something's wrong. You shouldn't have that. Get the idea? So y'all can use the chain rule, correct? Yes, we can all use the chain rule. Fantastic. That's wonderful. Because we're going to use the chain rule quite a bit. Okay, so in Mathematica, how would I do it? Well, what I'm going to do is I'm going to define my function like this. And then what I'm going to do is I'm going to say I want to take a derivative with respect of f with respect to time. How come it doesn't come up right? Well, it's with respect to time, yeah. And do you, right? I mean, you know, I didn't say it, but you know from the discussion that theta is a function of time, right? You know that, right? And you're saying, well, wait a minute, that ain't right. But if I were to say theta is a constant, did I get it right? Well, what's happening is Mathematica thinks it's a constant. You didn't tell it it's a variable. Right? You didn't tell it that theta was a variable. You see the idea? Right? It thinks it's a constant unless you tell it otherwise. Okay, here's what I need to do. I need to tell it that this guy is a variable. So I'm going to go in and say, okay, yeah, function is cosine of theta. And I do a square bracket, t square bracket. Now what I'm doing is telling Mathematica, theta is going to be a function of time. Okay? If it's a function of something else, temperature or whatever, then I would also say comma, 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 and I'd list everything that it's a function of. So that then when it takes derivatives, it knows what to do. Okay? So I end this guy and say, okay, that's my function. Now what do you think I'm going to do? Capital D, and then I'm going to say take the derivative of f with respect to time. Did it get the right answer? What's that tick? This thing here. That's how it does a dot. Okay, so that's how it does its dots. I don't know why. They didn't ask me. I would have told them to put dots on it. Okay, see that? This is the same thing that you got by hand. With me? Okay. That's the last bit of theory. I think I've covered all the theory that comes out of the for all the stuff that's on the test. All I'm going to do now is I'm going to start working some problems. Everybody okay with that? And you have 2 more homework assignments before the exam. Okay? All right. You're all awful quiet. Yeah. I do not. Anybody got a small screwdriver? I can't even loan you a calculator. I give you my keys. You can go get one out of my office. He's got a calculator. He said you can borrow. Anything else? Okay. Let's do some problems. And let's see. I have 8 of them that I'm ready to talk about. Anyone in particular you want to see? 150? Okay. I'll do 150. Hey, he's got a screwdriver. Wonderful. Yeah, right. Okay. Man, thing keeps getting away from me. 150. Okay, 150. Two particles, A and B, start at the origin O. And is it big enough you can see? Let's see. Two particles start at the origin and travel in opposite directions along a circular path at constant speeds. Determine the time when they collide and the magnitude of the acceleration of B just before this happens. Okay. What the heck are you going to do? Bless you. Anybody got an idea what to do? No? Huh? You can count what you know? Is that what you said? That's good. What I like to do, is that me? No, that's somebody else. Okay, what I like to do is if I don't know for sure, before I'd say, I don't even know what I know, right? I just start writing equations, okay? But yeah, I like that. Okay, so if you're kind of can think that through, do that, right? Because then that'll help you organize it. What I would do is I'd say, well, look, in this chapter, I have x and y, right? I've got r theta, and I have tangent normal, and I want to try and determine which one of those techniques I'm going to use on this guy. Yeah? Oh, you have no? Okay, so which one? How would you decide? I mean, you know the answer, right? Because it's out of tangent normal. It's got to be tangent normal. What do I do? Remember? I'm going to rule them out, right? Which one is the least common? In the real world, the least common. Tangent normal is the least common in the real world, so I'm going to start there and I'm going to say, okay, do I know the kinds of things I need for tangent normal? What do you need typically for tangent normal? You need what? Do you have to have a circular path? You have to know the path. You have to know the path, and what that means is you got to be able to get the radius of curvature and things like that, right? So you got to get the radius of curvature, so you got to kind of know the path. What else do you need? Is it r dot for tangent normal? That's the r theta. Okay, I think they call it radial and transverse or something, but it's the r theta equations, right? So I don't need r. Well, radius of curvature, if that's what you meant, yes. Okay, I won't disagree with that. You need speed, right? You need speed and you need radius of curvature. A change in speed, correct? Is that right? Good. Okay, so this is 12,150. Okay, so you need speed, change in speed. Guess I'll call it little v dot, right? And you need radius of curvature. Okay, so now I'm going to read the problem, and I'm going to see if I've kind of got those things. Two particles start at the origin, travel in opposite directions, circular path. Okay, do I know rho? Okay, so I know rho, good. I know the path, that's that one. How about speeds? Do you know speeds?
Yes.
Ah, okay, so I know speeds. Do I know speed dot? Change in speed. Okay, it's constant, so d dt of a constant? 0. Okay, so I know everything I need for tangent normal. I'm going to pick tangent normal. Okay, all right, so I'm going to pick tangent normal. Then it says, okay, they begin at some point, they move at this speed, determine the time when they collide. Okay, so when they collide, I know something about their positions, right? Okay, so what I'm thinking I'm going to do is I'm going to try and pick up some partial credit by writing equations for their position. Make sense? Now, do you have any equations for position? What are they? Where do they come from? Remember from the very beginning, it looks something like this. They kind of look like this, right? X equals x0 plus v0t. You remember those? Plus 1/2 at squared. Are these any good? But those were for a straight line. This is on a curve. Exactly. So what's happening is you're always on that tangent, right? So what we're going to do is apply this instead of, if you want to, you can call it S for arc length maybe. Maybe that helps you keep it straight, right? But because you're always on the tangent of that path, if I just use these equations along the path, but it has to have a constant acceleration along the path, right? So if this thing was speeding up for a little while and then slowing down, then speeding up, then slowing down, that'd be hard, right? But I can use these equations. And let's call it SA for the position of A along the curve, and SB. Is that okay? All right. So SA equals, okay, what's, right, because there's the acceleration is 0, right? So what I'm going to do is I'm going to say, okay, what's the original S at the beginning? Starts at O. Is that our origin? Is that a good origin? Okay, so O is our origin. Okay, so it's equal to 0 plus, how fast is it going? 0.7? Okay. 0.7 times t. Which way is positive? Is it? Okay, then did I write the equation correctly? I did? So at time equal, where's A? Oh, okay, I was thinking A was going that way. All right, okay, my mistake. Yeah, right. Okay, so how many equations? One? How many? Two? What are they? Yeah, one equation, how many unknowns? SA, do you know SA? Do you know T? No? Okay, so are you done? No. And you kind of expect that if there's two bodies, you know. Now in the real world you can have 22 bodies and only 2 are important and you got to tease it out. But in textbook problems, they usually give you just exactly what you need, right? Which kind of makes it easier. Okay, so SB. SB equals. Okay, plus 1/2. What's the acceleration of the body A? Constant speed. So, you know, so this is plus 1/2 times 0. Okay, SB equals, does he start at the origin? Okay. What's the speed? 1.5 t plus 0, because he has 0 acceleration, right? Okay. Now how many unknowns? 3. How many equations? 2. Okay, I'm not done. What's missing? Can I say what again? Yeah, the distances traveled are different. So I can't set SA equal to SB. What can I do? Is it SA plus SB? And then, okay, so why is it A plus B? Okay, let's see if that's the case. So let's say, for example, time was 1. Where's SB? Positive or negative? Negative. At time equal 1, where's A? What if you add them together? What I'm getting at is they're going this way, right? Right? They're gonna go like this. One's headed this way, one's headed that way, and then eventually they're going to collide. I need to write that fact that they collided. I can't say they're equal. Right? They're not. I can't say A is equal to B because A is going slow, right? So let's say it only gets to here and B comes all the way around because he's going faster and he gets over here. So I can't say SA equals SB. Okay, if I add them up, okay, this guy's negative, 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 really, really a whole lot of negatives.
But they equal them to the distance.
You got the right idea. I'm just trying to figure out what formula. Right. You know what you want to do is you want to say it's one circumference, right? SA and SB are one circumference. Okay, let's write that down. You see where I'm headed?
Yes.
Right? But it's not A equals B. It's not A equals B. Right? Is it A plus B?
Yes.
Is it? Okay, so this is a positive quarter. This is a negative 3/4, right? and you add negative 3/4 plus 1/4, what do you get? Negative 1/2. See, it's that negative that's screwing me up. Is it minus? Okay, so let's say, is it minus? Okay, this goes 1/4 positive. This guy goes negative, 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 negative 3/4. So I'm going to take positive 1/4 minus a minus 3/4. Does that give me one circumference? Okay, so what should my formula be? SA minus SB, and what should it equal? The circumference, right? Okay, so SA, bless you, minus SB equals, okay, what's the circumference? The distance around a circle. 2 pi times R, right? 2 pi, somebody say something? Yeah, 2 pi times the radius. And the radius is 5. Okay? SA minus S. Now how many equations you got? 3 equations, 3 unknowns? So we can solve it, right? Yeah.
How are we just assuming that one's going to be traveling 3/4 in one direction?
No, no, I'm just trying to make you stop and think. Now, should I add these guys? Because everybody was saying, Adam, Adam, Adam. Okay, well, look, before you just jump to conclusions, let's see if it works, right? And since I don't know what the answers are, I'm just going to make something up. We'll say, okay, let's let this guy go 1/3 of the way, right? But people think quarter's better than third. Let's say A goes 1/3 of the way. Then B will go 2/3 of the way, right? Add 1/3 and 2/3, what do you get? Not what you expect, right? You know what you want to say. You want to say that they're going to come around and hit. One circumference they're going to hit. We're just trying to figure out, should I add? Should I subtract? Should it be B minus A? Should it be A minus B? What should it be? Right? What should it be? Right? Don't jump to conclusions and say, well, obviously you add them. Well, how do you know? Plug in one number and see if it makes sense. And if you're really paranoid, plug in 2 numbers, right? Because sometimes 0 is special, right? And so, right? So plug in two things and say, well, if this one went 1/3 and this one went 2/3, would this formula still work? Yeah? Okay, I'm in. Got the idea? Right? But what I would do is I'd say, well, look, when I face this problem, I don't know what to do. So I'm going to look for some partial credit. So what I do is I say, okay, is it tangent normal? Is it r theta? Or is it the xy? So I showed you kind of how to think about that to eliminate them. Aha, it's tangent normal. Okay. Still don't know what I'm doing, but they say something about the positions of these guys, so I'm going to write a position equation. So what may be a little bit new right now is the fact that these formulas were for straight lines. But I think you can realize that, oh, wait a minute, I can apply this to a circle or to any wiggly path. It makes no difference. Any wiggly path, because the velocity is always tangent to that path. Right? Now, for example, if you're going around in a circle, right, like the Indy 500, right, it's not a circle, but anyway, you're going to go around and around and around and around. You have to tell me how far along there you've done so many laps. Well, then I know the distance that you've gone. Does that make sense? Right? So you have to, kind of interpret that. Okay, so that was maybe new, was the fact that you could use these equations on a circle. And then the other thing that was new is you have to kind of realize it's not always adding them. It's not always setting them equal. But you do know what it is that you're supposed to do. They hit after they've gone one circumference. Make sense? Okay. Since we can solve it, why don't we do it? You want to do it by hand? This one's not too bad, right? This one's not too bad, but you can do it by hand, or how would you like to do it? Mathematica. Yeah, okay, let's do Mathematica since you insist. I don't think I mandated you have to use Mathematica, did I? Okay, because I have 2 classes, I can't remember who I told what to. I recommend it, but you don't have to. And this you could do by hand if you wanted to. But anyway, I'm going to quit just because I'm not sure what I've done already. And I'm just going to type the equations in. Equation equals. I have SA equals 0.7 times t. And I have SB equals minus 1.5 times t. SA minus SB equals 2 pi times 5. Enter. And then I say solve. EQ for SA, SB, and T. Oh man, what'd I do? I'm about to panic. Oh my God. Oh my God. Oh my God. You see this? It says, man, there ain't no solution to that. What did I do wrong? He's already got it. He's trying to. I put ST. So what happens is when you get this, odds are you type something wrong. Right? And so you have to go back. If you're on an exam and something like this happens, right? This is a dynamics class, not a Mathematica class. And you go, oh my God, raise your hand. I'll come over and try to help you find your mistake. I can't always find it, right? So you don't want to make mistakes. But if something like this happens, you just call me over and I'll say, there's your problem, or I'll try to. Or else I'll say, there's something wrong with your equations. In other words, you got the wrong set of equations. You better go back and stop and think about it, right? It's not a Mathematica, it's a dynamics problem. Okay? Does that make sense? So I'll try to help you. Okay, so this should be B. There we go, much better. Let's get this guy out of the way. Darn it. Okay. How's that? Okay, now what was it that they wanted me to find? Because it was something else. Yeah, the time, well, the time they collide, I got that. The velocities. Yeah, okay, so they want the time they collide, I got it. The magnitude of the acceleration of B just before it happens. Okay, magnitude of acceleration. So what is acceleration? Remember the formula? You're going to put it on a cheat sheet, right? Okay. You might create your cheat sheets now so that you, when you come to class, you know where everything is, right? And it's, yeah, the accelerations in tangent normal, there's a tangent component of acceleration. Do you remember what that's equal to? V dot. Okay, what's V dot for body B? 0. So the acceleration in the T is 0. That comes straight off the formula. It's V dot, right? Which is 0. And then how about the normal? Maybe I should say ANB. ATB and ANB, right? Tangent of B, normal of B. What's the formula for the normal? V squared. Okay, so it's speed squared equals speed squared. That would be 1.5, is it? 1 point. No, it's 1 point. Isn't the speed of B 1.5? Okay, 1.5 squared divided by radius of curvature, which was 5. And bang. So what's the magnitude of acceleration? 0 squared plus 0.45 squared, square root 0.45. Yep.
What's that orange one?
I hit the wrong key on Mathematica. I don't know what it's trying to tell me, but it's saying you typed the key wrong. It'll go away eventually. I typed something wrong, got that little orange thing. I have no idea what that is. Okay, did I get everything done? Okay, yeah.
I thought we saw, like when we were putting in the other equation for position, we said acceleration.
Okay, which component of acceleration is 0? You hear what she's saying? She said, I thought we said the acceleration was 0. Acceleration along the path, right? Because what those equations are doing is saying, where along the path am I? It depends on how fast you're going along the path and if you're speeding up along the path. So the AT was 0, right? But if you're on a curve, even if you're not changing your speed, right? I'm not speeding up, but I am on a curve. I'm going to have an acceleration that way. Does that make me speed up? No. Does it make me cover more ground? No. That's why that component of acceleration never goes into the x equals x0 plus. You see that? It's always this way. I'm going faster. I'm going to get even faster, even faster. Does that make sense? So along the path, you're not speeding up. So that's the tangent component of the acceleration. But if you change direction, you will have an acceleration. Doesn't make you go faster, doesn't make you go slower, makes you fall out of the car if you're not buckled in. Yeah.
Why did you put the ATB and A and B?
This is the acceleration and the tangent of body B, and it was 0 because the speed's not changing. This is the acceleration and the normal of body B, and it's speed squared over radius. How's that? Is that good for 150? Okay. How about we do, I think I've done 167.
Oh, I have one more question.
Okay.
On that one,
Yeah.
you put that it was negative 1.5, and then you typed in that it was just 1.5. I know it doesn't matter because it's squared. But
Right. You should put in a negative.
okay.
Yeah. But it's going to square, so what? Who cares? Okay. Let's see. How about let's see, 167, I think I did. Yeah. Didn't we do 167? Car travels along circular curve? I did that last time. Yeah? Okay. Then let's try 171. There we go. Okay. I can't get both of these up here. Well, let me shrink it down. Maybe you can still see it. No, almost. Can y'all see that? 171. 171. The slotted length is pinned at O. Yeah, I guess you can see it. Slotted length, this is that blue one, is pinned at O. And as a result of the constant angular velocity, theta dot, it drives the peg P for a short distance along the spiral guide where theta equals radians. Determine the radial and transverse components of the velocity and acceleration P at the instant when theta equals pi over 3. All right. Now, what we either have xy, we have r theta, and we have tangent normal. Which one is this? Should be rather obvious, right? It's r theta. If you weren't sure, then what I do is I say, well, Tn is the least, for the real world, right? It's the least useful. So throughout my career, I've used that less than I've used any others. Okay, so what do you need to know for Tn? Speed, a change in speed, radius of curvature. I don't have any of those, right? So I'm going to rule it out. What do you need for radial and transverse? You need R, R dot, R double dot, theta, theta dot. Those are the things that are given. So I'm going to use that one. Okay? So it wants me to find, gives me theta dot, drives the peg. They want to know the velocity and the acceleration of P at the instant. Okay, should I start with the acceleration? No, what should you start with? You always start with the velocity. There's two reasons for that. Number one, the velocity is usually the easier one. So while you're really confused, do the easiest one first. Okay? Second thing is what you'll see is most of the time, many of the times, you'll need something from the velocity in order to do the acceleration. Right? So you won't be able to finish the acceleration until you do the velocity anyway. So you always start with the velocity and then do the acceleration. Okay? So that's what I'm going to do. Okay, so let me find my iPad. So here we go. This is 171. Okay. All right, what's the formula for velocity? Okay. And your book uses U's for the vectors, right? Plus R theta dot. Okay. Let's see if I can plug in. Let's go back to the formula. or the problem, and see what it says. Okay, theta dot. Theta dot's 3. I got that one. It says that r equals 0.4 theta. Can I find r? How? How are you going to find theta? Yeah, it's given, pi over 3. Okay, so this is 0.4 pi over 3. Okay, so I got the r. How about the r dot? If r is 0.4 pi over 3, r dot would be 0. Is it 0? Why? Sure looks like 0 to me. Right? Isn't that a constant? What's the derivative of a constant? 0. So why isn't r dot 0? Oh, theta is a function of time. Oh, got it. So really what you want to do is you want to differentiate this thing right here. Right? I don't know if this has happened to you in calculus. I was always making this mistake. Apparently I still am, right? They want the derivative at some point. So I'd stick in the theta equals whatever, and then I take a derivative. No, that's not what you do, right? So what you want to do is you want to take a derivative of this guy right there. Okay, can you do that? What do you get when you take a derivative of that? 0.4 times theta dot? Okay, so r dot equals 0.4 theta dot. What happened to the chain rule? How come I didn't use the chain rule? Or did I? Did I use the chain rule? Sure did. What's the derivative of something to the 1 power? Bring the power down, 1 times the stuff being raised to a power to the power minus 1, right? So it's like this. What's the derivative with respect to theta of 0.4 theta? Well, it's 0.4, bring the constant out front, bring the power of theta down, theta to the power minus 1, times the derivative of the stuff being raised to a power. Theta to the 0, that's 1. So you did use the chain rule. You just didn't realize it, right? I don't mean try to confuse you. All I'm saying is chain rule's always been there. You've been doing it. You just maybe didn't know it. It's always been there. Okay? But anyway, that's the derivative right there. Can I figure out what that is? Can you give me a number?
Yeah.
What is it? Yeah, so they told me theta dot was 3. Is that right? 3?
Yes.
Okay. So then r dot equals 0.4 times 3. Do you have everything you need to plug in? Can you plug in here? Do you know the r dot? Yep. Do you know the r? Do you know the theta dot? Yep. So you can plug in. Okay. Let's get the acceleration. What's the formula for acceleration? This one's a little harder. It's got 4 terms. R double dot minus R theta dot squared, thank you very much, UR plus Yep. There you go. Okay, the R I've got, theta dot I've got, R dot I've got, theta dot I've got, R. What's theta double dot? Why? Yeah, theta dot's constant. Okay, so I've got all those terms. So I'll write that down so it's not lost. Theta double dot is 0. Okay, how am I going to get R double dot? That's the only other term. Is it 0? Cool. How do you know? Is it? Right. So I'm going to take a derivative of this guy right here. I'm going to take this derivative right there. Right? So R double dot equals 0.4, right? Bring that constant out front. Chain rule gives you this. And theta double dot is 0. You're right. So theta double dot is 0. And for those of you that were saying, because this is a constant, yes it is, because 0.4 is a constant, and theta dot they said was constant. So yeah, R dot is constant. You're right. So it's equal to 0. You don't have to do all this monkey business. Okay, so take a look at when I took that derivative, right? How many dots you got on the left-hand side? 1. How many dots you got over here? 1. Okay. So that, at least gives me a good feeling. All right, how about this one? 2 and 2. See how it matches up? Okay. So that helps you know whether or not you applied the chain rule properly. Okay. Plug and chug from there. You want me to keep going, or is that good enough? What else did they ask me to do? Find the radial and transverse components of the velocity. Okay, that's it. Just plug and chug, plug the numbers in, get the numbers out, boom, you got them. You want to keep going? Okay, we'll keep going? All right. You want to use Mathematica? Because that's the only calculator I have. Where did it go? Oops. At the very bottom. Man, I can't find it. Let me get all this mess out of the way. Where did he go, man? Wow. I'll find it. Looks like it may have disappeared. I'll look at it on the tape and reconstruct it. Okay. Mathematica. Here we go. Let's see. 171. Enlarge it so you can see. Do 200. I'm going to quit just in case. All right. So I have V in the radial direction is R dot. R dot is 0.4 times theta dot. All right, and then V theta is, beg your pardon?
So you don't need to put the equation and equals and all that?
No, because I'm not going to solve for it. I already know the numbers. I'm just going to plug in. Right? I don't have to solve anything simultaneously. Right? So R theta is equal to, or V theta is R times theta, oops, theta dot. Let's see, AR is R dot dot minus R theta dot squared. The calculator would be so much easier. A theta, I'll call it, A theta equals 2 R dot plus R theta dot dot. Did I do something? Oh, instead of an R. R dot. Oh, 2 R dot theta dot. R dot. I didn't put the theta dot either, did I? Yeah, a calculator would be so much better here. R dot. 2 R dot theta dot. Did I get them okay? Okay. Now, what's theta dot? Let's see. Theta dot is 3. What was R dot? R dot, RD is what I'm calling it, right? RD equals 0.4 times 3. What is R double dot? R dot dot. 0. What is theta dot double dot? Theta dot dot. That was 0. I think I got them all. Yeah, you have a question?
You named theta dot wrong.
Did I? Tell you what, get a calculator and just put the numbers in there. because I'm not typing it right. They're numbers. Just take it, boom, boom, boom. Somebody get a calculator. You got a calculator. You just fixed it. Okay, so VR is R dot. 0.4 times 3. What's 0.4 times 3? 1.2. VR equals 1.2. Okay? V theta is R. What's R? R is 0.4 times pi over 3. .4 times pi over 3.
Where did you get the pi over 3 from?
That was the angle, theta, right? So R equals 0.4 theta, pi over 3. Did you get it? 0.4 pi over 3 is R. I mean, we're just multiplying numbers, right? I mean, I want to do something else. You're just multiplying numbers. You're just going to take your calculator, 0.4 times pi, divide by 3, boom, that's R, put it there. Theta dot's 3, boom, boom, right? Okay? I mean, this is not dynamics. Let's do some dynamics. You can take your calculator, punch it in. All right, good. Let's move on. Let's do another problem. You're looking at me like I'm crazy. No? Okay, that was 171, is that right? Okay. How about this one? $179. Did I do this one yet? Oh, I did. Okay, then I did 167. Okay, let's try 185. How's about this one? 185. The slotted arm AB. So it's looking at this picture here. Slotted arm AB rotates counterclockwise with a constant angular velocity. Determine the magnitudes of velocity and acceleration of peg P at theta equal 30 degrees. The peg is constrained to move in the slots of the fixed bar CD and rotating bar AB. Okay, how would you do this? Is it tangent normal? Do you know the path? Yeah, you do. Yeah, you do. Yeah, it's stuck in that bar DC, so it's going up and down, up and down. So yeah, you do know the path. What's the radius of curvature? Infinity. All right, do you know the speed, change in the speed? No? Okay, well, let's skip that one. How about R theta? Does that sound good? Yeah, R theta sounds pretty good, so I'm going to use R theta. X and Y. I'm going to do this with something that we're going to use a little bit later on. It works for all problems. You're welcome to use it, especially it works well if you have Mathematica. But I'm going to do it in another way, and then I'll do it with R theta. I'll show you two ways. Okay? 185. So here we go. All right, 185. Okay, so what's happening is you got this slot right here. And the peg is in that slot. Okay, and he's being driven by this rod right here. I'm just going to draw a line. He's being driven up that slot by that rod, right? And they give me this angle here, theta. And they tell me a little bit about the angle theta. Okay, and they want the velocity and the acceleration. So they want the velocity and acceleration of the peg P. Okay, here's what I'm going to do. I'm going to say, well, I'll tell you what. I'm going to write the position of the peg, and then I'm going to take a derivative. And that should get me the velocity. You agree? Change of position is velocity. And then if I take another derivative, I'll get acceleration. So what I want to do then is I want to write the position of this guy, and I want to put him in terms of an angle that, or something that's known to me. So for example, they tell me theta, and they tell me theta dot, and they tell me theta double dot. So I'd like to write the position in terms of theta. And you know how to do this. It's real simple. All I'm going to do is I'm going to go from point A, and I'm going to say I'm going to walk until I get to point P. So I'm going to walk this way. How far? 4 feet. So I'm going to walk in the horizontal direction 4 feet. So I'm going to say, okay, the position, POS, equals 4 in what direction? I'm going to go to the right. So I'm going to put a coordinate system here. I goes to the right. What do you want J to do? Straight up? That's what I want it to do. So those are my two directions. So this is east and north or whatever, right? So I'm going to go a distance of 4 in the east direction. And that's going to put me right here at the bottom of this thing. And now which way am I going to go? Up. Okay, that'll be the, bless you, that'll be the J. So I'm going to go up. How far? I want it in terms of angle, because angle is what I know. How far am I going to go? It would be this distance right here, R sine theta, right? R sine theta. Okay, so then I'm going to go R sine theta J. So far, so good? Okay. Now, what's a variable in here? What changes? Does 4 change? Well, it just went out. Oh, here we go. Theta changes, right? What about the R? Does it change? Okay. Yeah, it does, right? Because, you know, as it goes up, doesn't this distance get a little further? Right? The hypotenuse changes. So R is a variable, and so is theta. So what I'd like to do is I'd like to figure out what R is. Can you tell me what R is? That distance right there. Give it to me in terms of an angle. How about this? R cosine theta equals 4. Does that work? Okay, so R cosine theta. Okay. Okay, so what I'm going to do now is I'm going to take a derivative. I don't want to do it by hand, so I'm going to open up Mathematica. Oh, there it is. That's what you were telling me. It's all at the very bottom. Okay. Yes. Okay. Well, that's the same thing I did. So you're right. Yeah, you're right. You see what he's saying? I didn't see that on the picture. Is that different than what I wrote? Right, R, if you divide by the cosine, you get the secant. So 4 times the secant is this distance R. So I guess that was a hint, but okay. I didn't need it. I'm tough, right? Anyway. Okay, so here's, let's see, this is the Mathematica that I aborted on. And where's the other one? Yeah, here it is. Okay, so here's the Mathematica that I was using before. I'm going to quit. Whoops. Yeah. Yeah, no man. What the heck? Quit. Okay. All right, so here's what I'm going to do. I'm going to say the position equals 4 times I plus R, and R is equal to 4 divided by cosine of theta. Now, I have to tell Mathematica that theta is a variable, right? So how do you do that? You remember? Okay. And so that's the cosine. 4 over the cosine, that's the R, close parentheses, times the sine of theta, t, and that's the position. Oh, times J. There you go. How's that? Is that good? Everybody okay with that? Okay, now what do you want to do to get velocity? Take a derivative of what? Position with respect to what? Not theta. T, it's always with respect to t. Whoops, why is it not typing? Derivative of position with respect to t. I mean, you could do it by hand, right? Couldn't you do that by hand? Where does this guy come from? How come there's a dot there? Because of the chain rule, remember the chain rule? And this is a velocity. There should be a dot. There should be a dot in there, right? So anyway, so 4j, what direction is he going? Up, right? He's going up. We knew that. He's stuck in a slot. He can't get out of the slot. He can't go side to side. He's got to be going up. Does that make sense? Okay, so how am I going to find the acceleration? By the way, you know the theta. I think it said it was 30 degrees. You know the theta dot, right? Isn't that given?
Yes.
Okay, so you can take out your calculator now and you can punch into this thing. You agree? That's the velocity. How am I going to find acceleration? Take a derivative of velocity, right? Acceleration equals the derivative of velocity with respect to time. Okay, can you plug numbers into this? Do you have all these numbers? You know the theta, right? You know the theta. Yeah, how about the theta dot? Is it constant? Theta dot's constant? Theta dot's constant. What's theta double dot? 0. So can you plug into this? What direction is it? It's in the J? Going straight up and down? Okay. How was that? Is that decent? If you have Mathematica, it works out great. If it was me, I would not try to take this derivative, because I don't remember Calculus 1 that well. Right? But with Mathematica, bang, just smack it. It comes out real good, right? Only thing you have to do is be careful when you type. Any questions about that? Everybody okay? Okay. You want me to show you if I were to use R and theta? Just for kicks? I mean, I would accept this on a, I mean, I put numbers in there, but I think that's acceptable. How much time do I have? Oh, I got plenty of time. Okay, so let me do a theta and do the same problem with R and theta. Okay, velocity equals R dot UR plus R theta dot U theta. Okay? How am I going to find R dot? How are you going to find R dot? How about you just take the derivative of that thing right there? Okay, can you take the derivative of 1 over the cosine? I bet you can. But you also have Mathematica. Huh? You want to do it by hand or with Mathematica? Huh? Okay, or the secant, if you remember how to do that. Secant tangent, I think, or something like that. Right? So you can take a derivative? Okay. What else do you need to know? R. Okay, you can get the R because you know the theta, right? Right, you just plug it theta in here and you get the R. Theta dot, you know. So once you take that derivative, you can bang it in there and you got your velocity. Now if you notice, this one's going to have a UR and a U theta. It's going to have 2 pieces. How come this one has 2 pieces and the other one only has 1 piece? They'll be both. And so what'll happen is, let's say you have it up here, okay, on this diagram. Where's the UR on this diagram right up here? Where's the UR? How do I find which direction UR is? You always do what? Draw a line from where to where? from the origin of your r and theta straight out past the point. So it goes like this. So this is the UR. Whoops. That's the UR right there. Right? Where's the U theta? How do you find the U theta? In which direction? In the direction of positive angle. Right? So you're going to go counterclockwise 90 degrees. So it's going to go this way. I'll draw it down here so it's more room. U theta. So what you're going to have is you're going to have a component along here. You're going to have a component along there. Those two components are going to add together and give you 0 in the x. They'll have to. Okay? So the piece along here and the piece along there, if you add them, they're going to give you 0 in the x. But it's not obvious to you. Is it? It's not obvious, but it has to be because it's going straight up and down. But those are the components. Now it asks for the magnitude. So how are you going to find the magnitude? You're going to have a number here. You have a number here. How do you find magnitude? Square root, magnitude. Magnitude is the square root of the r dot squared plus r theta dot squared. You'll have the same value that you get from the previous. You'll have the same speed. How are you going to find acceleration? R double dot minus r theta dot squared plus 2r dot theta dot plus r theta double dot. Right? And now you plug and chug. How are you going to find the r double dot? Take two derivatives of that. You know the r, because you know theta. You know theta dot. You know the r dot. You took it before. You know the theta dot. You know the r. What's the theta double dot? 0. So you're going to end up with an r component and a theta component. You want magnitude. How are you going to find magnitude? Square root. Square root of one squared and the other guy squared. Make sense? Which one of these do you like? Which one was easier? This r theta or the writing position? I think writing position is usually the easiest thing to do. Okay? You're welcome to do that on an exam if you can. Right? In simple little geometries like this, it's not too hard. As a matter of fact, very rarely do people who do this for a living use this kind of formula because you normally don't have something where you can define everything from an origin. Things are much more complicated. And so rather than trying to booger it around to where it will fit, they typically do this. Write the position, differentiate twice. Especially since you have something like Mathematica, because that was the hard part, taking derivatives. Any questions?
Would it also work like if it wasn't on the set? Is this one just going up and down?
Right. What do you mean, like if this were a curve or leaning over? Oh yeah, you could do it that way as well. In fact, I'll give you an example. I'll make one up and show you. Anything else? Any questions? Okay, and so the time is, you want me to do another problem or you want to leave? Do another problem? Okay, how about 131? 131. All right, 131. At a given instant, the train engine at E has a speed of 20 and an acceleration of 14. I didn't do this one yet, have I? Okay, because it sounds familiar. Maybe I was doing it at home or something. I did the train? Okay. You want me to finish it or no? Different problem, okay. 150 I did, 131 I did, 124. Let's see if I've done 124. 124. The car travels along the circular path such that its speed is increased by, I'm pretty sure I didn't do this one, that its speed is increased by 0.5 e to the t. 0.5 e to the t, where t is in seconds. Determine the magnitudes of its velocity and acceleration after the car has traveled s equals 18 meters starting from rest. Neglect size of the car. Okay. What am I going to do with this? Right? I've got xy, I've got r theta, I've got tn. Is this which one is it? Let's check Tn. Okay, in order to do Tn, you got to know speed. Do you know anything about speed? Yeah, what do you know? Is it, right? At, you know the tangent. You know it's on that path. To me, it looks like a Tn. Right? Because there's no r, theta dot, theta double dot. I don't have those. Right? So I'm thinking Tn. Is that right? Is that good? And it's out of the Tn chapter anyway. Okay, so let's see. They want the velocity. Let's go and see if we can find the velocity. What's the velocity? It's the let's see. The acceleration along the tangent is equal to time rate of change of velocity or speed. Is that right? If you look at just the tangent, because we were doing one earlier, right? Just the tangent going around that circle, right? Tangent acceleration, if it was the derivative of the velocities, wasn't it? You remember that? Okay. So here's what I'm going to do then. I'm going to come in and say, let's see, this is 12-124. Okay. So the things on this curve, that guy right there, AT is equal to 0.5 e to the t. And what I know is the change in speed, dv dt, is equal to at. Remember that? Is that good? So what I'm going to do is I'm going to write dv dt equals 0.5 e to the t. What kind of equation is that? It's a differential equation. How do we solve differential equations in this class? Separate variables. So I'm going to write dv dt equals 0.5 e to the t. Whoops. Separate the variables, dummy. Okay, dt. And then I'm going to integrate and integrate. So this is v equals, okay, what's the integral of 0.5 e to the t? 0.5 e to the t plus what? Plus an arbitrary constant. How do you find that constant? Okay, so at time equals 0, what? Starts from rest? Yeah, it says it does. Starting from rest. So what does that mean? 0, v is equal to 0 when t equals 0. Okay. So 0 equals 0.5. What's e to the 0? 1 plus c. So what's c? Minus 0.5. So the speed is equal to 0.5 e to the t minus 0.5. Okay, so I've got the speed. And they said, let's see, acceleration, magnitudes of the velocity and acceleration after the car has traveled. Okay, so what do I know? I know that v dot equals 0.5, whoops, oh, it's after it's traveled 18. I thought that was the time. Okay. You want to finish this on Wednesday, or you want me to post it? Okay. On Wednesday, all I'm going to do, Wednesday, Monday, and well, next Wednesday is your exam, right? So this coming Wednesday, this coming Monday, you're going to take a quiz, because the TA didn't show up. So you're gonna take quizzes, make sure you have your papers. And then I'm just gonna do a problem, try to get you ready for the exam. Now, when I start doing problems, I don't like to pick the problems because then you're gonna start playing psychological games. Is he gonna do a problem that's on the exam or isn't he? Right? So to get away from that, you ask me for the problem and I'll do my best to do it. And if you happen to catch one that's on the exam, that's fine. But I'm going to keep a straight face and keep going. Okay? So come with questions or problems you want to see. You have a question? See what?
I just decided that I'm not dividing by it won't work, which means I can't. It just won't work. I tried it while we were traveling and people want to do it That'll be awesome. Thank you so much.
But if you have to stay up.
Yeah. All right, thank you.
So yeah, time sensitive.